So the next one I was asked to make a video for was number 29. So A says find f of a plus h. So that tells me I want to put a plus h everywhere I see x in the formula. So that's a plus h quantity cubed. Well, remember what cubed means. It means write it 3 times and multiply those all together. So it's a plus h times a plus h times a plus h. So the squaring part, that we've done a bunch of times now, so that's a squared plus 2ah plus h squared for these two, and then I need to multiply that by a plus h. I'll show you a way a student showed me that I thought was pretty slick, so I like this way a lot now. I put the terms of the first polynomial across the top here, a squared, 2ah, and h squared. And then I put the terms of the second polynomial down the side. And now at the intersection of each row and column, I multiply. So a squared times a is a cubed. A times 2ah is 2a squared h. Then I'll have an ah squared. And then if you put them in alphabetical order, it's easier to find like terms. So I'm going to have a squared h, and then 2ah squared, and h cubed. So the nice thing about this method is the like terms are close together geographically. So I'm getting a cubed, and then see how I have 2 a squared h's and then one more, so 3a squared h. Then I have 2ah squared and one more, so 3ah squared plus h cubed. So this is the part A, where it says just find f of a plus h. Okay, then the next thing you're asked to do is find f of a plus h, so take that part you just did, subtract off f of a, and then divide that by h. So if your function is f of x equals x cubed, then f of a is going to be a cubed, and that's what's going to go here in this second spot. So I'm going to have a cubed plus 3a squared h plus 3ah squared plus h cubed from above here, minus the f of a all over h. So this is the step where everything without a factor of an h in it better cancel, and it does, yay. So then I'm going to factor out h from each of the remaining terms in the numerator. And cancel that h in the top and the bottom because that's a 1. And multiplying by 1 doesn't do anything, so we don't continue to write it. So this is what's called the difference quotient, also called the slope of the secant line, and also called the average rate of change. It's just different interpretations. So then the C part asks you about the instantaneous rate of change. Well, the instantaneous rate of change is the limit as h goes to 0 of the average rate of change. So we put a 0 in everywhere we see an h, and we get 3a squared. So this is the formula for the instantaneous rate of change. And then we're asked specifically about when a is 5. So we're going to say when a is 5, the instantaneous rate of change is 3 times 5 squared, or 75.